So in this part of the demo, we're going to focus on a new feature of the Openbox. In this representation, we have another new feature. This is a product role set, but the roles that there's only one component of this product. And the Openbox interprets this as saying, well, simply form the product of this set with itself. So here, we've simply got a set of roles that we call nodes. And each node is either connected or not connected. Each pair of nodes are either connected or not connected. So the roles here are going to be pairs of the form node 1, node 1, node 1, node 2, node 1, node 3, node 3, node 4, node 4, node 5, and so on. And each role is going to have the property of being connected in that direction or not. Again, to demonstrate a feature of the application, here I'm going to display the values as icons. I'm going to suppress the name of the role, and I'm going to use the check icon, which is here, to display the fact that two nodes are connected, and the cross icon to display the fact that these nodes are not connected. So here I launch the Openbox, drop the graph representation on the Openbox, restart the Openbox and create a new diagram. Here the default value is that everything is not connected. Here is the role node 2. Node 2 is not connected to node 2. Node 2 is not connected to node 3. And just by clicking, I can change the values here. So this is a way of representing a graph in the mathematical sense, a set of nodes with edges between them. These are directed edges because we have both the role here, node 2, node 1, so this says there's a connection from node 2 to node 1 for maybe, and this one is node 1, node 2 that says there's a connection in the opposite direction. So this gives us the ability to represent directed graphs, possibly with cycles, where this node is connected to itself. So this is one way of representing graphs. But that's not a very useful way of representing graphs, or not a very familiar way of representing graphs. So here's another example. In this particular representation, we have, for example, this is again a product role set with one set of roles. So this is again going to be paired with itself. And these are suggestively station names: Victoria, Westminster, Paddington, Temple, Knightsbridge, and Marylebone. And the value set here is that these pairs of objects are either not connected or connected by the district line, circle line, Victoria line, or Bakerloo line. We've done something here with the product role set. We've said that it's symmetric, which means that we know that if a pair of objects are connected in one direction, they're also connected in the other direction. So we don't generate both pairs of roles. We only generate one of the pairs of roles. And we've said that these are reflexive, so we don't generate the connection between a station and itself. We assume that in fact that station is always connected to itself. So here's the specification of how we want to realize this representation. We want to realize it as a map using a map feature display panel. And this controls how we display the whole feature. And then the roles, individual roles, are going to be displayed using a widget we call the map link. And the map links take a color map. We saw this in the example of the traffic light, where we were able to specify a color for pairs of roles. So the Bakerloo line, for example, will be represented using this color, which is the official London Transport color of the Bakerloo line converted into Java. And not connected, I used a little trick here. This is a color that is completely transparent, and so not connected roles will look like they're not present in the map. Okay, so now when I drop this representation, the specification of this representation onto the Openbox, and restart the Openbox, now when I create a diagram for this representation, I see something more like a map with the nodes representing each of the stations in my network. And I can create, and these are all not connected, which is why we have links here, but the links are transparent, so we can't see. And then simply by clicking, I can create links between stations and change the value of the role here by changing the colors. This is the Circle line, the Victoria line, the Bakerloo line, connecting these stations together. And with a little bit of patience, we could actually represent an accurate description of the London subway map involving these stations. There's one more kind of representation that we might think about as being part of the a single feature indicator system, and that is a histogram. So suppose we want to represent the sales for a particular logic textbook by month. So here the roles are the months of the year, and here the values. Now again, we are specifying the values by their types, and this is the sales, the number of books that were sold in a particular month. So here we are going to use the type of integer to represent the values here, and we're just going to choose a value of 10. And here the features are going to be displayed using a histogram feature display panel, and the roles are going to be displayed by a widget that we call the histogram bar. So now when we drop the representation on the Openbox, we get a new representation system. Again, we open Openbox, create a new diagram. This is a histogram, all of the values are 10. Simply by clicking on different points in this histogram, I can choose different values for this, the bars of the histogram. So this is another example of a single feature indicator system. The features are the bars for the month of January or the month of February, and the value is displayed as the length of the bar, and the value is an integer, so that's a perfectly reasonable translation of the way to represent this particular kind of data. Again, just to demonstrate this, I can make an edit to January's sales, for example, and now these two histograms are contradictory.